Okay, this is section 6.2, transforming random variables. We're going to actually do things that applied in chapter 5. So I'm just going to jump right in to an example because we already know what a probability distribution looks like from 6.1. So this is saying that somebody is considered a full-time student if they take between 12 and 18 units. X is, so again, we always define X. X is that a randomly selected student. So X is the number of units that they're taking. So they take between 12 and 18. And again, you can only take whole units. You can't take a partial unit. So this is discrete. And this is the probabilities of those. So again, each probability is between 0 and 1, and the sum of the probabilities adds up to 1. So if we calculate and interpret the mean and standard deviation of X, so again, I'll show you the symbols. So again, the mean, I would say mu sub X, or I could say E of X. Remember, these two are interchangeable. And I'm just going to show, again, a little bit, what are we doing to find the mean? We just take X times its probability, plus 13 times 10, plus dot, 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 18 times 0.15. And that should give us 14.65. And the standard deviation of X is going to be the standard deviation. And again, if I show part of the formula, I'm taking each individual X minus the mean that we just found, squared times its probability. And then next one, 13 minus 14.65, squared times its probability, plus dot, 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 all the way to the end, and our standard deviation should be 2.056. And if in context, these are units. So if I want to, so I did the calculation, now what's the interpreting? So the interpreting is the average number of units taken by a full-time student, and I'm just going to say El Dorado Community College to abbreviate. The average number of units taken by a full-time student is about, and again, I don't want to round here because it is an average, so I'm going to say 14.65 units. And what is the standard deviation? The average distance each student, each individual student, units taken, is from the mean. So again, standard deviation is spread. What's the average distance from each student's units taken from our mean of 14.65. Okay, so that one again, I showed how we did it by hand, and again, you can take the time to do all that on the calculator. I didn't want to take up the time in the video showing you pushing the buttons. But again, I also showed you at the end of Class Wednesday how to do it quickly on the calculator. So in this next one, I'm going to do it on the calculator. Okay, so again, these are transforming. So we started off with the number of units taken. Down here, we're transforming it to a different distribution. I'm going to call it a different letter. So X stood for the number of units taken. T stands for the tuition cost. So each tuition is 50 per unit. So where do you think I got the 600, 650? Well, if they take 12 units times $50, that is $600 for tuition. 13 units times $50, and you can see how these numbers were created. So each unit they take is $50. This is going to be the tuition cost for taking those same amounts of units, and the probabilities stayed the same. So if I want to find the mean and standard deviation of T, so I'm going to go to Stat, Edit, and I got some stuff in my list, so I'm going to clear those out. So just because I like to use list 1 and list 2. So if I put in the 600, the 650, so you can, hopefully you're pulling out your calculators and doing this with me. And then putting the probabilities in list 2. Okay, so I've got my X's or my T's in list 1 and the probabilities in list 2. So how do I quickly find the mean and standard deviation? Again, I go to Stat, I go over to Calc, I choose one variable, Stats, and my values are in list 1, and the probabilities, my frequency list is in list 2. I'm going to calculate that. And so my mean of T, and again I'm using the correct symbols, so the mean of the random variable T is going to be $732.50 because this is money, and the standard deviation of T is right here, the $102.80. So that's how I can quickly find that mean and standard deviation without having to punch all those buttons on the calculator. Not that that's horrible. Okay, so next question, again, this came up in a previous lesson. What is the effect of multiplying or dividing a random variable by a constant? So the effect is the shape will stay the same. If it was approximately normal, it's going to stay approximately normal. If it was skewed, it'll stay skewed. I'm just changing the values on my x-axis. I'm not changing the shape. But the mean and standard deviation, I'm going to abbreviate standard deviation, but the mean and standard deviation are both multiplied by that constant. So I could have done, I didn't even have to do this part that I just showed you on the calculator. I could have just taken my answer from part A. Guess what 732.50 is? If I had taken my mean of 1465 from up here and multiplied it by the $50, I would have had my mean immediately. Same thing with the standard deviation. If I had taken my standard deviation from the part above and multiplied it by 50, so I didn't have to type all those in my calculator to find those two numbers. I just did that so that I could remind you how to do it. But this would have been the quicker way. If I had it for the individual units and I know the transformation is multiplication, I can just take my mean and standard deviation from that distribution, multiply it by that 50, and I get my new mean and standard deviation quickly. Okay, so we're going to do an addition transformation. So what happens if they just have student fees, like maybe paying for a gym or something on campus? So that's an additional $100 per semester in fees. So again, I'm just taking these values up here and adding the $100. So 600 plus 100 gives me my total new cost. So this is tuition plus the fees. This is now what the students have to pay. So again, calculating the mean and standard deviation. So what do I have to do? Now I'm going to show you on the calculator, just to refresh you how to do it. My probabilities didn't change. I just have to add to these. So I just need to change that to 700. Because I want you to see what happens. So make sure I didn't make any typos. So again, I'm going to go Stat, Calc, one variable Stats, list 1, list 2, calculate. So what is my new mean? So my new mean for the random variable C is 832.50. Again, I can see from the part up here, it just took my mean for the tuition, added 100, and there's my new cost. But what happened to the standard deviation? Notice it is exactly the same. Adding a constant just shifts it left and right. It doesn't change its width. So this is a good proof of To get the new mean, I can do the addition, but remember from the previous chapter, addition does not affect the spread. It only affects the center. So again, shape, center, and spread. So shape remains the same. As the distribution before it. The center increases or decreases if it's subtracted. And the spread stays the same. And we actually addressed this in chapter 5, so hopefully you remember that, and it just continues on here. Okay, so a linear transformation, remember y equals mx plus b, that's our linear equation of a line. How does it affect the mean and standard deviation? So a linear transformation, it involves adding or subtracting. Subtraction is just adding a negative, or multiplication, division, or both. Okay, so what you'll see it look like the mean of, let's say I have a new random variable y, it's a plus b times the mean of x. So if I have an original distribution of random variable x, I can show both multiplication and addition to get my new mean. And then the standard deviation of a new random variable, if I want to transform a random variable x to random variable y, is going to be the absolute value of b, because again, standard deviation can't be negative, times the standard deviation of x. So once I found the standard deviation of x, so again, only the addition affects the mean. If there is some a addition or subtraction, it doesn't affect the spread. Okay, so let's use that little rule here. So sometimes a teacher wants to scale a test. They don't want to necessarily just add 5 points to everybody. Maybe they just want to scale it through multiplication and addition. So x was the raw scores. It tells us it was normally distributed. It tells us the mean and standard deviation. The professor decides to scale it by multiplying by 4 and adding 10. So y is going to be the scaled score. So find the mean and standard deviation of y. So the mean of y is going to be the addition, so adding 10. So 10 plus 4 times the mean of x. And the mean of x was given as 17.2. So that gives us a new score of 78.8. So the mean of the randoms of the scaled score. So somebody that got a score before of a mean of 17.2, now the mean score of the test is 78.8. The standard deviation of y, again, is only going to be the 4 times the standard deviation of x. So that's just going to be 4 times 3.8. So the standard deviation of the scaled test is 15.2. So again, only addition affects the center, not the spread. Just multiplication affects both. And then this goes back to chapter 2. What's the probability that a randomly selected student has a scaled score of at least 90? So I could write it like this. At least 90 means 90 or above. So I can do my normal CDF. And since it's greater than 90, 90 is my lower bound. I'm going to put a really big number as my upper bound. And then the mean was 78.8, and my standard deviation was 15.2. So again, if I am going to do the calculator speak, I do want to define what each of these are. So this says that it's the normal distribution. So that's going to equal 0.2306. So there's about a 23% chance that a randomly selected student and I would get in the habit of after you answer the question to write it in a sentence, because a lot of times on the AP exam they're looking for the context, and this is where you'll take care of that. Has a scaled score of at least 90. And you end up really just rewriting the sentence that they gave you. You're not writing something new. You're just basically repeating this again. Okay? I'm going to show us how to do a simulation. So now this moves on to combining random variables, not necessarily transforming them, but I might have two distributions that I want to add together or subtract. Okay, so we've got one distribution of the height of male speed daters. Again, it tells us it's a normal distribution, mean and standard deviation. We also have a height of female speed daters and their mean height and standard deviation. I want to figure out what is the probability that a randomly selected male speed dater is taller than his randomly selected female speed dater he's paired with. So the simulation, I'll show you how to do it, and it actually shows you how to do this in the textbook as well. So you will go to your math, probability, and now we're just going to do random normal. We haven't done this one before. So random normal, and I did this yesterday. This is the females. Let me go ahead and put the males in. So the males was, oh, I do have the males in there. So the mean height of the males was 68.5, females 4. I went ahead and just did 100 trials, but we could do 500 trials if we wanted more information, but this was actually enough. So I want to, because I don't want to see the 100 numbers on here, so I'm going to store it. So again, remember your store button right here. I'm going to store it into list 1. So that is going to create 100 numbers into list 1 of the random heights of males. And then I'm going to do the same thing with the females. So random normal. And so this is going to put in the males. So I put in, what, 68.5, 4, and then I did 100 trials. And then I'm going to do the same thing, and I stored that into list 1. So I'm going to do the same thing with the females. And the females was 64 and 3, and I'm going to store that into list 2. So again, math, probability, number 6. This is going to change to 64 and 3, and again I'm going to do 100 trials. And I'm going to store it into list 2. You can just see the little thing turning up there, so it's thinking till it finishes. Okay, so now and I'm going to show you what the distributions look like. So just to kind of review, if I wanted to make a histogram of the males, I'm going to go second y equals to get a stat plot. I'm going to turn it on. I'm going to choose histogram, which already is, and my males are in list 1, so we need to switch that back to list 1. Again, to get a quick window, I do zoom, and number 9 is stat, so I can just press the number 9 and it gives me a nice window. Now it looks a little skewed to the right. If I had done more trials, if I did 200 or 500, it probably would have looked more normal, but the shape was generally like that. And then if I look at the females distribution, I'm just going to go back and change this to list 2. And again, do zoom 9. And this is the female distribution. So this one actually looks like it has some lower on the left. Okay. So, but they're roughly approximately normal. So those are the shapes. So what I want to do is afterwards I want to look at what's the shape after I combine them. So what's the probability that the male is taller than the female? So what I want to do, how can I figure that out? I could look at each list and count how many times the number in list 1 was bigger than list 2, but I got 100 numbers here, so that's kind of time consuming. So I'm going to subtract them. So if I do L1 minus L2, I'm taking the males minus the females. So if it's greater than 0, then the male was taller than the female. And if it's less than 0, then the female was taller. So if I get any negative differences, the female was taller than the male partner that they were paired up with. So the quickest way for me to subtract is I'm going to go over to list 3, and I'm going to go up to where it's highlighted, and then down here I'm going to put in what I want it to do. So I want it to do list 1 minus list 2. So down here, but I've got to be up here, so it's going to create a whole new list subtracting these two. And there's the differences. Now again, so I can scroll down. Now I want to know how many times, I really want to count the positives, but to me it's probably easier to count the negatives because there's going to be fewer of them and just subtract from 100. So I can see 1 already, and I could scroll through this, but I can do something else. I can do second stat. So I did second stat to do something to the list, and I'm going to go over to operations, and I want to sort it. So I'm going to just press number 1, and I want to sort list 3, because list 3 is the differences. And I'll press enter, and it'll say it's done. So now if I go back to my list and look at list 3, now my negatives are, so it's going from least to greatest. So now I can just count how many negatives I have. And when I say count, if you look over here, I'm on the 16th number. So that last negative number was number 15. So in my 100 trials, so 15 females were taller, which means what? It means that 85 males were taller. So just find the complement. So if I want to know the probability that a randomly selected male is taller according to my simulation, so I'm getting the habit of writing that, because again, this is 100 really isn't long term. So according to my simulation, the probability a randomly selected male will be taller than the randomly selected female that's paired with is about 85%. That's why I did 100 trials, because it's easy to find percents. 85 out of 100, 85%. Now let me look at these. So let's go back and talk about what is the, oh, I should have done that first. I should have done the shape of the, so I'm going to go back to stat plot, and I'm going to look at a histogram of the differences. I guess the order doesn't really matter. So I'm going to change that to list 3, zoom 9, and again, notice that the distribution should stay the same. So if both distributions individual were approximately normal, then the differences would also be approximately normal. Okay, and a last couple of examples. So again, the non-simulation approach, and when I say don't worry about the 4 steps, there's the 4 steps in your textbook that say state, plan, do, conclude. Don't worry about doing it exactly like them. I just want to start off, I kind of skip the state step and go right to the plan. So the first thing I need to do is define my random variable, and I usually will start with x if nothing else is taken. So I'm going to let x equal the weight of a randomly selected apple. Okay, so certain variety of apples have weights that are approximately normally distributed. So they're saying one apple weighs about 9 ounces with a standard deviation of 1.5 ounces. But we're getting bags of apples, so we're selling bags of 12 apples. What is the probability that the sum of the 12 apples is less than 100 ounces? So x is the weight of one apple, and I'm going to let t equal the total weight of 12 apples. Okay, so what am I doing to find the mean of t? So the mean of t is going to take the weight of x1 plus the weight of x2 plus the weight of... So this is where it gets tricky. You would think, well, the shortcut way is if I want to total the average weight of 12 apples, can't I just do 9 times 12? If you write down 9 times 12, believe it or not, they won't like it and give you credit for it because we're not multiplying. This is addition. So we are adding 9 plus 9 plus 9 plus 9 12 times. So you actually have to show that you didn't just do 12 times 9, that you added each of those individual weights. So, but of course on my calculator, I'm going to go and do 12 times 9. Okay. So if x, the mean is, so the mean of x was 9 ounces. So the mean of t is going to be the sum of 12 apples. So again, make sure you're showing that it's addition, not that you just did 9 times 12, because otherwise it looks like instead of adding, you're using the multiplication, and it didn't say that. So kind of important there. So what is the mean? And then I also have to find the standard deviation. So the standard deviation of y was 1.5. And so to find the standard deviation of t, remember I can't add standard deviations, I can only add variances. So I've got to do this 1.5. So I'm taking the standard deviation squared, and I'm doing that 12 times. Because I'm able to add variances, and then at the end, again, I'm going to take the square root of the whole thing. So after you do all that math, you get a standard deviation of 27 ounces. So the reason I have to do all this is because I want to answer the question, what's the probability that the sum, which is t, is less than 100 ounces? So again, I can do my normal CDF because it told me it was normally distributed up there. And again, I'm doing less than 100. So again, if the mean is 108, 100 is somewhere down there. So this is what I'm finding. So again, if I did a sketch, that's what I'm actually finding. So my lower bound is a really small number. That's what I put in the calculator. My upper bound is the 100. The mean and standard deviation we just calculated. So to get that answer, I'm going to get, whoops, I forgot to take the square root of that. The standard deviation is 5.2 ounces, not 27 ounces. So let's change that to 5.2. Okay. So if I put that in the calculator, then I'm going to get an answer of 0.062. So my conclusion, again, I do want to conclude, and I want to conclude with a statement, and I should have given myself more room to write. So there is about a 6.2% chance that 12 randomly selected apples will have a total weight of less than 100 ounces. So maybe you don't want to write so big up there so that you have room to write where I didn't have room to write. Okay, one last example. Okay, so B is the amount of books spent. So we're going back to our community college. The mean is 153, and standard deviation of 32 is the cost of books. So before, the mean before was 832. So the mean of C plus B is going to be the 832 that we found before plus the 153, and so that means our new cost for the students is $98.50. And then the standard deviation of C plus B, guess what? We can't calculate it because we can only add variances because C and B are not independent. We can only add variances when the random variables are independent. And why are they not independent? Because your book cost will be affected by the number of classes you take or units taken. So that is going to affect your cost. So that wraps it up for 6.2, and I'll see you soon.